General solution of the differential equation y square dx plus x square minus xy plus y square dy equals 0 is, so first uh, given is y square dx plus x square minus xy plus y square dy equals 0. So this is equal to rearranging this term, so this will be y square dx equals minus of x square minus xy plus y square dy. This will be minus y square by x square minus xy plus y square equals dy by dx. That is equal to dy by dx equals dy by dx plus y square by x square minus xy plus y square equals 0. So this is a simplified differential equation. We have to find the solution. So this is in implicit form. So we substitute y by x by y. X by y equals v. Therefore, or we can alternatively we can use we can say dx by dy taking reciprocals here. So dx plus dy plus dx by dy plus x square minus xy plus y square by y square is equal to 0. So since we have dx by dy, we will put x by y equals v. Therefore, dx by dy will be v plus y dx dv by dy. So dx by dy will be v plus y dv by dy plus x square minus y will be x by v minus x into x by v plus x by v the whole square divided by x by v the whole square. This is equal to 0. So v plus y dv by dy plus x square minus x into x by v plus x by v the whole square divided by x by v the whole square equals 0. So simplifying this, we'll be getting v plus y dv by dy plus, simplifying this term we can get v square minus v plus 1. This is equal to 0. So rearranging the terms, that is bringing y terms on one side and v terms on other side, we get dv by v square plus 1 is equal to minus dv by dy. So integrating both sides, we get integration of 1 by v square plus 1 is tan inverse of v, and integration of 1 by y dy is log y. So since there is a minus sign, we put minus log y plus c. So this will be tan inverse of v is x by y plus log y plus c equals 0. This is a solution. So the answer is tan inverse of x by y plus log x, tan inverse of x by y plus log y plus c. So we'll compare the solution. There's a correction here, it is supposed to be y. So this will be tan inverse of x by y plus log y plus c. So the answer is A, tan inverse of x by y plus log y plus c. solution of the differential equation dy by dx equals 1 plus x plus y plus xy is, so given differential equation is dy by dx equals 1 plus x plus y plus xy. So this can be factorized as dy by dx equals 1 plus x into 1 plus y. The product gives this term. So separating this, we get dy into 1 by 1 plus y is equal to 1 plus x into dx. So integrating it, we get this will be log of 1 plus y, and this will be x plus x square by 2 plus c. So the solution is A, log of 1 plus y equals x plus x square by 2 plus c. If dy by dx plus 1 by root of 1 minus x square equals 0, then the solution is, so given is dy by dx plus 1 by root of 1 minus x square is equal to 0. So rearranging terms, we get dy by dx equals minus 1 by root of 1 minus x square. So bringing x terms on one side and y terms on the other side, we get dy equals minus 1 by root of 1 minus x square dx. So integrating both sides, we get y is equal to minus of sine inverse. Integration of 1 by root of 1 minus x square is sine inverse of x. This will be minus sine inverse of x plus c. So shifting this term to our LHS, we'll get y plus sine inverse of x equals c, which is option A. Solution of the differential equation dy by dx equals 1 plus x into y by y minus y minus 1 into x is, so given is dy by dx equals 1 plus x into y by y minus 1 into x. So first step is separate y and x terms. So bringing y terms on LHS, we get y minus 1 by y into dy is equal to 1 plus x by x into dx. This can be written as y, we'll split this. So this will be 1 minus 1 by y dy, and this will be 1 by x plus 1 dx. So integrating both sides, we get differential integration of 1 is y, integration of 1 by y is log y. So minus log y is equal to log x plus c. So shifting terms to one side, we get log of x plus log of y plus x minus y equals c. So by law of logarithm, log of x plus log of y is equal to log of x into y. So log of x into y plus x minus y is equal to c, which is option C. Integrating factor of the differential equation cos x into dy by dx plus y sin x equals, so to find the integrating factor, we have to convert this in the form of dy by dx plus py equals q. So we have cos x alongside dy by dx, so we'll divide throughout by cos x. So we get dy by dx plus y into sin x by cos x equals 1 by cos x. So sin x by cos x is tan x, so dy by dx will be dy by dx plus y tan x equals sec x. So here we got p equals tan x. So integrating factor is given by e raised to integral p dx. So this will be e raised to integral tan x dx, which is equal to e raised to integration of tan x is log of sec x. So log of sec x, which is equal to sec x by law of logarithm, that is e raised to log m to the base e is equal to m. So integrating factor is sec x, so the answer is C, sec x. Solution of the differential equation x dy by dx equals y plus x square s. So first we divide throughout by x, so we get dy by dx equals y by x plus x square by x. So shifting terms on shifting this term to shifting this term to LHS, we'll get dy by dx, and this is nothing but x. So dy by dx minus x equals y by x. or we can say write dy by dx minus y by x equals x. So this is in the form of dy by dx plus px equals q. So integrating factor will be e raised to integral p, that is minus 1 by py. So this is py, that's why we put this term in LHS. So y is minus 1 by x into y. This will be minus 1 by x into y. This is in the form of py. So p is equal to minus 1 by x. So this was dy by dx plus py equals q. So integrating factor will be e raised to integral p dx. So p is here minus 1 by x. So this will be integral of minus 1 by x dx. So integration of minus 1 by x is log x minus log x. So log e raised to minus log x, that is equal to e raised to log of x raised to minus 1. So e raised to log x raised to minus 1 to the base e is equal to 1 by x. So integrating factor is 1 by f. So therefore the solution is y into integrating factor, that is 1 by x, is equal to integration of q into integrating factor into 1 by x, that is into dx plus c. So x gets cancelled. So we are left with y by x equals integration of 1 is x plus c. So in the options we are using a instead of c. So we'll use a as a constant. So y by x equals x plus a. So multiplying throughout by y, we get y equals x square plus ax, which is option C. The solution of the equation dy by dx plus root of 1 minus y square by 1 minus x square equals 0 is, so first we bring this term to RHS. So dy by dx will be equal to root of minus 1 minus y square upon 1 minus x square. So bringing y terms on one side and x terms on the other side, we get minus 1 by root of 1 minus x square into dx is equal to 1 by root of 1 minus y square into dy. So integrating this, we get this is sine inverse of x with a minus sign, and this is sine inverse of y, and we add a constant c. So bringing x and y together, we get sine inverse of x plus sine inverse of y equals, let this be sine inverse of c. Since both of these are a constant, so it doesn't matter. So sine inverse of x plus sine inverse of y is sine inverse of x into 1 minus y square plus y into root of 1 minus x square. This is the formula for sine inverse of x plus sine inverse of y, and this is equal to sine inverse of c. So sine inverse of a, this term is equal to sine inverse of c. So therefore the angles must be same, that is sine x root of 1 minus y square plus y root of 1 minus x square is equal to c, which is option B. X into root of 1 minus y square plus y into root of 1 minus x square is equal to c. Solution of the differential equation sine of dy by dx equals a with y of 0 equals 1 is, so given is sine dy by dx equals a. Therefore dy by dx will be sine inverse of a. Now this is in the form of dy by dx plus py equals q, where p is 0 and q is sine inverse of a. We don't need this right now. Okay, so uh, we bring x terms to one side and y terms to other side. So dy will be equal to sine inverse of a into dx. So integrating both sides, we get y equals x into sine inverse of a plus c. So this is what we got after integration. Now given is y of 0 is 1. That is when x equals 0, when y equals 0, x equals 1. When y of 0 is 1 means when x equals 0, y is equal to 1. So we put the values. So x is 0, y is 1 plus c. So therefore c equals 1. So we got the value of constant. We substituted. We get y equals x sine inverse of a plus 1. That is equal to 1 y minus 1 equals x sine inverse of a. That is equal to 1 y minus 1 by x equals sine inverse of a. So therefore a will be equal to sine of y minus 1 by x, which is option B. Solution of differential equation y dash minus y equals 1 is where y of 0 is minus 1. So given is y dash minus y equals 1, that is equal to dy by dx minus y equals 1. Therefore dy by dx equals 1 plus y. So bringing y terms on one side and x terms on the other side, dy, this will be 1 by y plus 1, dy will be equal to dx. So integrating both sides, we get log of y plus 1 equals x plus c. So taking anti-log on both sides, that is exponentials, this will be y plus 1 equals e raised to x into e raised to x plus c. That is equal to e raised to x into e raised to c by law of indices. So y of 0 is minus 1. That is when x is 0, y is minus 1. So we substitute the values. X is 0, so this will be e raised to 0 into e raised to c, and this will be minus 1 plus 1. So e raised to c is 0, e raised to c is 0, therefore so we got e raised to c as 0. So we substitute the values in this equation, the solution. So y plus 1 equals e raised to x into e raised to c, but e raised to c is 0. So this term, whole term is 0. So y plus 1 equals 0. So y plus 1 is 0. So y of x, we have to find y of x. So y will be minus 1. So for any value of x, y will be minus 1. So the answer is C, minus 1. The solution of the differential equation x square plus y square into dx equals 2xy dy is, so this is a implicit function. So we'll be using y by x equals v substitution. So first put y by x equals v, that is y equals vx. So derivating this, we get dy by dx equals v plus x dv by dx. So putting this here, first we simplify this. So this will be dy by dx is equal to x square plus y square by 2xy. So we substitute this, we get v plus x dv by dx is equal to x square plus y is vx, so v square x square divided by 2 into x into vx. So taking x square common, we get x square into 1 plus v square by 2x square v. So x square gets cancelled, and here it is v plus x dv by dx. We are left with, now we take this to RHS. So this will be x dv by dx equals 1 plus v square by 2v minus v. So we got x dv by dx equals 1 plus v square by 2v minus v. So simplifying this, we get 1 minus v square upon 2v, and this is equal to dv by dx, x dv by dx. So taking v term on one side and x term on the other side, we get 2v upon 1 minus v square dv equals 1 by x dx. So integrating this, so here we substitute 1 minus v square equals t. So minus 2v will be equal to 2v dv will be equal to dt. So therefore 2v dv will be equal to minus dt. So you substitute this here. So this will be minus of 1 by t dt, which is equal to integral 1 by x dx. So this will be minus of log t integration of 1 by x is log x. So minus log t equals log x plus c. Let this be integration constant. But c here is t here is 1 minus v square. So this will be minus log of 1 minus v square equals log of x plus c. So therefore log of x plus log of 1 minus v square equals c1, where c1 is minus c. Let this be another constant. So by law of logarithm, log of x plus log of 1 minus v square is log of x into 1 minus v square, and this is equal to c1. But v is y by x, so this will be log of x into 1 minus y square by x square equals c1. So erasing the power, taking empty logs, we get x into 1 minus y square upon x square will be equal to e raised to c1. Let this constant be another constant c2, or let's say c, and let this be c2, since in the option they have given in terms of c. So this is c. So multiplying throughout by x square, we get c into instead we put this to RHS. So this will be x equals x square minus y square. We simplify it in this way. So we got x into 1 minus y square by x square equals e raised to c1, which is equal to c. So simplifying this, we got x into x square minus y square by x square equals c. So x get cancelled. So we get x square minus y square upon x equals c. So x square minus y square equals cx, or we can say x square minus y square, taking this here 1 by c equals x. Let this be constant, any constant. So this will be x square minus y square into, let's say, k, any constant, is equal to x. So from the options, if we compare it, x is equal to any constant c integration constant into x square minus y square, which is option B. The solution of dy by dx plus px into y is equal to 0 is this is the differential equation. We have to find the solution for this. So it is a linear differential equation. So this is in the form of dy by dx plus px equals q. So integration factor will be e raised to integral p dx. Here it is. So this will be e raised to. So this is the same thing. P of x is equal to p, that is p is a function of x. So we can write this simply as p. So e raised to integral p dx. So this is a integration factor. So the solution will be y into integration factor equals integration of q into integration factor dx plus c. But q equals 0, so this will be integration of 0 plus c dx y into e raised to integral p dx. So this will be y into e raised to integral p dx equals c. So shifting this term to RHS, we get y equals c e raised to minus integral p dx, which is option C. So a linear differential equation is given, dy by dx plus y by x equals sin x. We have to find the solution for this. So this is in the form of dy by dx plus px equals plus py equals q. So here p is 1 by x and q is sin x. So integration factor will be e raised to integral p dx, which is equal to e raised to integral 1 by x dx. Integration of 1 by x is log x, so e raised to log x. So this will be equal to x by law of logarithm, that is e raised to log of m to the base e is equal to m. So using this rule, we got x integration factor. So solution will be y into integration factor x equals integration of q, that is sin x, into integration factor dx plus c. So integration of x sin x is minus x cos x plus sin x plus c. So this is xy. So shifting this term to LHS, we get xy plus x cos x equals sin x plus c. Taking x common, we get x into y plus cos x equals sin x plus c, which is option A. X into y plus cos x equals sin x plus c. If x into dy equals y into dx plus y dy and y is greater than 0 and y of 1 is 1, then y of minus 3 is equal to what? So what is given is x dy equals y into dx plus y dy. So dy will be x shifting terms, rearranging the terms, will be getting x dx, x dy minus y dx upon y square. This is equal to dy. This will be getting after we rearrange the terms. So dy equals this. Now this is the formula for derivative of x by y, that is u by v, that is v into integration of u minus v into that is x into derivative of y minus y into derivative of x upon y square. So this is the derivative of x by y, and this is equal to y. So therefore we can say now we integrate this. So we can say y is equal to and this is negative sign minus, so y equals minus x by y. So therefore y plus x by y is equal to c. So y of 1, now y of 1 is 1, that is when x is 1, y is 1. So we substitute this these values here, so we'll be getting y 1 plus 1 by 1 equals c. So therefore c equals 2. So c equals 2. So therefore we can say y plus x by y is equal to 2. So we have to find the value of y of minus 3, that is when x is minus 3. So when x is minus 3, so this will be multiplying throughout by y, we get I'll solve it here. So multiplying throughout by y, we get y square plus x equals 2y. So multiplying throughout by 3, we get y square minus 2y minus 3 equals 0. So this is a quadratic equation, and finding the roots will be getting y equals minus 1 comma 3. But since y is greater than 1 greater than 0, so the answer will be 3 instead of minus 1, since it is less than 1 less than 0. So answer is 3, that is y equals 3 for x equals minus 3. So the answer is B, 3. X square plus y square into dy equals xy dx. If y of x0 equals e and y of 1 equals 1, then value of x naught is, so given is x square plus y square into dy equals xy dx. So this is equal to x square dy plus y square dy is equal to xy dx. So therefore x square minus xy dx is equal to minus y square dy. So taking x common, we get x into x dy minus y dx, and bringing this to LHS, we get minus y square. This is equal to dy. So applying bringing this to negative sign into the bracket, we get x by x into y dx minus x dy upon y square is equal to dy. Now this is nothing but derivative of x by y. So this will be equal to x by y into derivative of x by y, which is equal to, okay, x, there won't be y, so x into derivative of x by y is equal to dy. So dividing throughout by y, we get x by y equals d of x by y equals dy by y. So integrating both sides, we get, so what we got in the previous step was x by y, d of x by y is equal to dy by y. We integrated it, so we get x square by 2y square is equal to log y plus c. So now y of 1 equals 1, that is when x equals 1, y equals 1. So this will be 1 by 2 into 1 equals log 1 plus c. So log 1 is 0, so c will be half. So we got the value of c. So therefore x square by 2y square equals log y plus half is the solution. So we put x equals x naught. So and y will be equal to e. So when x is x naught, so that is x0 square divided by 2e square equals log e plus half. This is equal to, so this will be log e is 1. So bringing this term to LHS, we get x naught square divided by 2e square minus 1 minus half. This is equal to 0. So simplifying this, we'll be getting x naught square is equal to 3e square. So taking roots, we'll be getting x naught is equal to plus or minus root 3e, which is option A, root 3e. Solution of the differential equation y dx plus x square plus xy dy is equal to, so given is y dx plus x square y dy is equal to 0. So shuffling terms, we get y dx equals minus of x plus x square y dy. So this is equal to uh, uh, we can write this as minus x dy minus x square y dy. So we shift this term to LHS. So y dx plus x dy is equal to minus x square y dy. That is equal to 1 by x square y dx plus x dy. This is equal to minus dy. Now we divide both sides with y. So this will be 1 by x square y square, that is xy the whole square. And this is the formula for u into v for x and y. So this will be d of xy. So derivative of xy is y into derivative of x, that is dx, plus x into derivative of y, that is dy. So derivative of xy, this is, and this will be minus dy by y. So integrating this with respect to dy and integrating this with respect to d of xy. So this is in the form of 1 by xy the whole square, that is xy raised to minus 2. So this will be minus of 1 by xy, and this is minus log c, that is log y, sorry, minus log y plus c. So shuffling the terms, we'll get minus 1 by xy plus log y equals c, which is option B. So it is given that sec x dy minus cosec y dx is equal to 0. We have to find the solution. So this will be sec x dy is equal to cosec y dx. Shifting y terms to one side and x terms to other side, we get 1 by cosec y dy is equal to 1 by sec x dx. 1 by cosec is sine, so sine y dy is equal to cos x dx. So integrating both sides, we get cos x so integration of sin y is minus cos y and cos x is sin x plus c. So shifting this to RHS, we get sin x plus cos y is equal to c, which is option D, option C. The solution of the differential equation 1 plus y square into tan inverse of x dx plus 1 plus x square 2y dy is equal to 0. We are supposed to find the solution of this differential equation. So given is 1 plus y square tan inverse x dx plus 1 plus x square 2y dy equals 0. So first step is we bring this term to RHS. So this will be we can divide divide by this and divide throughout by 1 by x square, 1 by divide throughout by 1 plus x square and 1 by 1 plus y square. That is this can be written as, or we can use do this 1 plus y square tan inverse of x dx is equal to minus 2y dy divided by 1 plus x square. Into. So bringing this term to LHS, we'll get tan inverse of x dx divided by 1 plus x square. What we are basically doing is putting x terms on one side and y terms on other side, and this will be equal to minus 2y by 1 plus y square dy. Again shifting terms, we get tan inverse of x dx, or we can keep this as it is. Now we integrate this with respect to x and with respect to y. So this will be, now put tan inverse x equals t. So differentiation will be 1 by 1 plus x square dx will be equal to dt. So this term is here, dx upon 1 plus x square. So this will be dt. So integration will be t dt is equal to, now similarly for this, let 1 plus u square equals u, 1 plus y square equals u. So therefore 2y will be, 2y dy will be du. So this will be integration of 2y dy is du. So du into 1 by 1 plus y square is 1 by u. So minus 1 by u. So now we integrate this. We'll get integration of t is t square by 2 and integration of 1 by is log u. So with negative sign, this will be minus log u plus c, a constant. Now t is tan inverse of x, so this will be tan inverse of x the whole square, and simultaneously we multiply throughout by 2. So this will be 2 into minus 2 into log of, now u is 1 plus y square, so 1 plus y square plus 2c. So we bring all the terms on one side, we'll be getting tan inverse of x the whole square plus 2 times log of 1 plus y square is equal to 2c, or that is c1. Let this be c1. So the answer is tan inverse of x the whole square plus 2 log of 1 plus y square equals c, a constant, which is option B. If dy by dx equals x plus y plus 1 by x plus y minus 1, then the general solution is, so given is dy by dx equals x plus y plus 1 divided by x plus y minus 1. So in this special case, we will be putting x plus y equals v. So differentiating this will be 1 with respect to x. So this will be 1 plus dy by dx equals dv by dx. So substituting this here, this will be dy by dx will be dv by dx minus 1. This is equal to v plus 1 upon v minus 1. So bringing this term to RHS, we get dv by dx equals v plus 1 upon v minus 1 minus 1 plus 1. So this will be 2v upon v minus 1 dv by dx. So we bring v terms on one side and x terms on the other side. So this will be v minus 1 upon 2v is equal to dx and dv. So we can now split this term. This will be v upon 2v minus 1 upon 2v dv equals dx. So now we integrate this. So v gets cancelled. So this will be integration of half minus 1 by 2v dv equals integration of dx. So previous step was integration of half minus 1 by 2v 1 by 2v dv equals integration of dx. So now we integrate this. So integration of half is v by 2, integration of half, and integration of 1 by 2v, that is log of half log v equals x plus c. So multiplying throughout by 2, we get v minus log v is equal to 2x plus 2c. So now in the option, we are given in terms of we are given y in terms of a single x. So what we'll do is we'll add an split this y into again x plus y, that is in terms of the original. We'll resubstitute this in the options. We are given in terms of y and x, so we'll bring y and x back from v. So v was x plus y, So this will be x plus y minus log of x plus y equals 2x plus 2c. So there is x on both sides, so x gets cancelled. We're left with y minus log of x plus y is equal to 2x plus c. Sorry, x plus c. So shifting terms on one side, we'll be getting y is equal to x plus log of x plus y is equal plus a constant, let's say c1. So this is the answer. So the answer is y equals x plus log of x plus y plus a constant, which is option A, x plus log of x plus y plus a constant. Which of the following is the general solution of the differential equation y into 1 plus log x dx by dy minus x into log x equals 0? So we are given that y into 1 plus log x dx by dy minus x log x is equal to 0. So this is a given differential equation. So we shuffle the terms. So this will be y into 1 plus log x dx by dy is equal to x log x. So now we shift x terms on one side and y terms on other side. So this will be 1 plus log x upon x log x dx. This is equal to 1 by y dy. This can be split into 1 by x log x plus log x upon x log x. So log x gets cancelled, we are left with 1 by x. So this will be equal to 1 by y dy. So now we integrate this. So integrating this, so here if we take log x equals t, so differentiation will be 1 by x dx will be equal to dt. So this will be 1 by t dt plus integration of 1 by x dx will be log x, and this is equal to log x log y plus say log c. Let this be a constant. Now integration of 1 by t is log t plus log x equals log y plus log c. Now t is equal to log x, so this will be log of log x plus log x equals log y plus log c. So by law of logarithm, we can say log of x into log x, that is log of a into log of b is log of ab. This is equal to log of y into c. So therefore x log x is equal to y into c. So if we compare it with the options, we get c, which is x log x equals y into c. The particular solution of differential equation log of dy by dx equals 3x plus 4y is when y is 0 and x is 0. So we have to find the particular solution for this one. So what is given is log of dy by dx is equal to 3x plus 4y. Particular solution means we have to find the value of the integration constant c and find the solution. So this is given, so therefore dy by dx is e raised to 3x plus 4y. We can write this as by law of indices. This will be 3x e raised to 3x into e raised to 4y. So now separating x and y terms, this will be e raised to minus 4y dy is equal to e raised to 3x dx. So now integrating both sides, we get e raised to minus 4 e raised to minus 4y divided by minus 4 is equal to e raised to 3x divided by 3 plus c. So when y is 0, x is 0. When x is 0, y is 0. So we substitute the values. So this will be e raised to 0 divided by minus 4 equals e raised to 0 divided by 3 plus c. So c will be 1 by 3 minus 1 by 3 minus 1 by 4, which is minus 7 by 12. So we got the value of C. So now we got the value of C. So we substitute it here in equation 1. So this will be e raised to minus 4y by minus 4 equals e raised to 3x by 3 minus 7 by 12, that is C. So we multiply throughout by 12, we'll get 12 into e raised to minus 4y by 4 equals 12 by 3 into e raised to 3x minus 7 into 12 by 12. So we are left with minus 3 e raised to minus 4y equals 4 e raised to 3x minus 7. So therefore 4 e raised to 3x plus 3 e raised to minus 4y minus 7 is equal to 0. So now we compare it with the options. So it is 4 e raised to 3x plus 3 e raised to minus 4y minus 7. So the answer is option C. Option C is the answer, which is 4 e raised to 3x plus 3 e raised to minus 4y minus 7 equals 0. The integrating factor of the differential equation 1 plus x square dy by dx plus y equals tan inverse of x's. So first we'll convert this in the form of dy by dx plus py equals q. So this will be, first we'll have to divide throughout by 1 plus x square. So we are left with dy by dx alone. So this will be dy by dx plus y by 1 plus x square is equal to e raised to tan inverse of x divided by 1 plus x square. So comparing this with the standard form, so p will be 1 upon 1 plus x square. So integrating factor is e raised to integral p dx. So this will be e raised to integral 1 by 1 plus x square dx. The integration of 1 by 1 plus x square is tan inverse of x. So this will be e raised to tan inverse of x, which is option C. The given differential equation is y into dy by dx plus is equal to x into y square by x square plus phi. Phi is a function. So phi of y by y square by x square divided by phi dash, that is differentiation of phi function. So phi dash of y square by x square. So this is given. So given is y dy by dx equals x into y square by x square plus phi into y square by x square, phi of and phi dash of y square by x square. This is given. So this is an implicit function. So we'll substitute y equals vx. So therefore dy by dx will be v plus x dv by dx. So y will be vx into x v plus x dv by dx is equal to x into y by x is v. So y square by x square will be v square plus phi of v square upon phi dash of v square. So shifting v terms on one side and x terms on other side, we'll be getting integration of v into phi dash of v square upon phi of v square into dv is equal to 1 by x dx. So this is what we got. Now we integrate both sides. So we'll be getting half log phi of v square, since numerator is a derivative of the denominator. we can write this half log of phi of v square, and since this was in a form of integration of t, so the integration of t square by 2, that is log of this was in the form of 1 by t, so integration of 1 by t was log t, where t was this. If we simplify this, we'll get this answer. So this will be equal to log x plus log c. Let this be constant, the integration constant. So half log of phi of v square is equal to log of x plus log of c1. So by law of logarithm, this will be log of phi of, now we resubstitute v equals y by x, so this will be phi of y by x, y square x square, that is y square by x square, or rather we can bring this to RHS, since in the options we are supposed to find the power of in the option we have RHS as x or either x square, so we'll try to find the power. So we'll bring this to RHS, so this will be 2 log of x plus 2 log c, that is equal to log of x square plus log of c square by law of indices. So that is equal to log of phi of y square by x square is equal to log of x square into c square, x square into c square by law of indices. So therefore phi of y square by x square is equal to x square c square. This can be written as c1 into x square, where c1 is equal to c square, which is also a constant. So the from the options we just proved that phi of y square by x square is equal to cx square. So the answer is C. Phi of y square by x square is equal to cx square. So given differential equation is dy by dx plus y by x log x equals 1 by x. So this is in the form of dy by dx plus py is equal to q. So first we'll find integrating factor, which is equal to e raised to integral p dx, which is equal to e raised to integral 1 by x log x dx. Now integration, here we can see derivative of log x is 1 by x. So we can write this as integration of 1 by t dt. So this will be log t, where t is log x. So this will be e raised to log of log x, that is equal to log x by law of logarithm. So integration factor is log x. So solution will be y into integrating factor, that is log x, is equal to integration of integrating factor into q, that is 1 by x dx plus c. So again, when log x equals t, put log x equals t. So 1 by x will be dt. So this will be t dt integration plus c, and this will be y log x simply. So integration of t will be t square by 2, but t is log x, so this will be log x square by 2 plus c. This is equal to y log x. So multiplying throughout by okay, first what we are given is when y is 1, x equals c. So we put x equals c and y equals 1 to find c. So what we found was y log x is equal to log of x the whole square by 2 plus c. So x equals c, y equals 1. We substitute the values, we get y 1 into log e is equal to log e the whole square by 2 plus c. So log e is 1, so this will be 1 is equal to 1 by 2 plus c. So c will be half. So we got the value of c. Now we resubstitute it. So this will be y log x is equal to log of x the whole square by 2 plus half. So multiplying throughout by half, we'll be getting 2y log x is equal to log of x the whole square plus 1. So dividing throughout by log x, we'll be getting 2y is equal to log x plus 1 by log x, which is option B. Option A, 2y is equal to log x upon plus 1 by log x. The given differential equation is 9y into dy by dx plus 4x equals 0. So we are supposed to find the solution for this. So 9y dy by dx plus 4x is equal to 0. So multiplying throughout by dx, we'll be getting 9y dy plus 4x dx is equal to 0. So integrating throughout, we get integration of y is y square by 2. So this will be 9 into y square by 2 plus similarly this will be 4 square by x square by 2 is equal to c1. So this is now we divide throughout by 18. So this will be y square by 4 plus x square by 9 is equal to c by 18. That is we divided throughout by LCM. So we got y square by 4 plus x square by 9 is equal to c by 18, which is equal to c1, a constant, let's say. So from the options we can say it is y square by 4 plus x square by 9 is equal to c, which is option B. The differential equation given is dy by dx plus 2xy equals y. So first we'll rewrite it. We are supposed to find the solution for this. So this will be is equal to y. So we bring this to RHS. Is equal to y minus 2xy. Taking y common, this will be y into 1 minus 2x. So bringing x terms to one side and y terms to other side, we'll be getting 1 by y dy is equal to 1 minus 2x dx. So integrating both sides, we'll be getting log of y is equal to x minus 2x square by 2 plus c. So y will be equal to e raised to x minus x square plus c, or rather we can say c into, since everything is a constant, assuming c1, where c1 is e raised to c. Since we are adding this, so we'll replace this with e raised to c, which is equal to c1. So this is equal to x minus x square, which is option A. Y is equal to c into e raised to x minus x square. The given differential equation is 2y minus 1 into dx minus 2x plus 3 dy is equal to 0. So we can write this as dx upon 2x plus 3 minus dy by 2y minus 1 is equal to 0. Shuffling the terms, that is. So now we integrate this. We'll be getting log of 2x plus 3 divided by 2 minus 1 by 2 log of 2y minus 1 is equal to, let's say, log c1 constant. So this is equal to log of 2x plus 3 minus log of 2y minus 1 is equal to 2 log c. So by law of logarithm, this can be written as log of a minus b is log of a by b. So this will be 2x plus 3 by 2y minus 1. And this is equal to log of c square. Now let this be another constant c1. So this will be, now comparing the inner parts of the log, this will be 2x plus 3 by 2y minus 1 is equal to c square, which is equal to c1. So we got this. and we compare it with the solution. So this is 2x plus 3 by 2y minus 1 is equal to C. The answer is C. 2x plus 3 upon 2y minus 1 equals C. The general solution of the differential equation dy by dx plus sine of x plus y by 2 equals sine of x minus y by 2 is given as dy by dx. Now we put sine terms on one side. So dy by dx will be sine of x minus y by 2 minus sine of x plus y by 2 minus sine of x plus y by 2. So this is in the form of sine of a plus b minus sine of a minus b. So sine a minus sine b, that is. So formula for this will be 2 into sine of b minus a. This is the formula for sine of a minus sine of b. So formula will be 2 sine b minus a, that is x plus y by 2 minus x minus y by 2 into cos of sine of into sine of cos of a plus b, that is x minus y by 2 plus x plus y by 2. So this is equal to 2 sine of y by 2. There's some negative sign, so minus 2 sine of y by 2 into cos of x by 2, and this is equal to dy by dx. So bringing y terms on one side and x terms on other side, we'll get 1 by sine y by 2 into dy by dx is equal to minus cos x by 2 dx. This will be dy minus 1 by sine of y by 2 dy is equal to minus cos of x by 2. 1 by sine is cosec, so this will be cosec of y by 2 dy is equal to minus cos of x by 2 dx. Now integrating both sides, we get integration of cosec is log of tan x. Integration of cosec is log of tan. So this will be log of tan of y by 2 by 2, log of tan of half angle, that is. So this will be log of tan of y by 4 divided by y by 2. So since this is y by 2, so we'll divide by the coefficient, that is half, and this is equal to sine of there's a 2 here, so 2 into sine of minus derivative integration of cos is sine, so this will be minus 2 into sine of x by 2 divided by x by 2 1 by 2 plus constant c, integration constant c. So in the previous step we got log of tan y by 4 divided by half is equal to minus 2 sine x by 2 by half plus c. So multiplying throughout by half, so this will be log of tan y by 4 is equal to minus 2 sine x by 2 plus 2c. So let this 2c be another constant c1. So this will be log of tan y by 4 is equal to c minus 2 sine of x by 2. So now we compare it with the options. So the answer is log of tan y by 4 is equal to c minus 2 sine x by 2, which is option B. Given differential equation is y minus x into dy by dx is equal to a into y square plus dy by dx. We have to find the solution of this differential equation. So what is given is y minus x dy by dx is equal to a into y square plus dy by dx. So first we expand the brackets, we get y minus x dy by dx is equal to ay square plus a dy by dx. Now we club it, we bring dy by dx terms on one side and remaining terms on other side. This will be y minus ay square is equal to dy by dx into, taking this common, a plus x. Taking y common here, so this will be 1 minus a into y is equal to dy by dx a plus x. So separating the terms, that is x and y terms, we'll get 1 by a plus x dx is equal to 1 by y into 1 minus ay into dy. So taking integrations on both sides, so for LHS it will be log of firstly we'll simplify this. So this will be integration of 1 by a plus x, and using partial fraction we can write this as 1 by y plus a upon 1 minus ay. So sum of these two terms will give us the previous term and into dy. So integration of 1 by a plus x is log of a plus x is equal to integration of 1 by y is log y plus a into log of 1 minus ay, minus into minus since there is a minus sign, plus log c. Let this be integration constant. So clubbing the log terms by using law of indices, clubbing this and this along with and this and log y and log c on RHS, and clubbing this term and this term on LHS, will get log of a plus x plus log of 1 minus ay is equal to log of y plus log of c. So by law of logarithm, this will be log of a plus x into 1 minus ay is equal to log of yc. So therefore a plus x into 1 minus ay is equal to cy. So comparing it with the options, this will be x plus a into 1 minus ay is equal to cy, which is option B.